Wonderful. Okay, at the end of my presentation, I'm going to be listening for the bells, okay? As he said, my name is Larry Clark. I am the CEO of Glucan Bio. We turn cheap biomass into valuable products. We start with the biomass, a problem in need of a solution. We've identified over 300 million tons of biomass that's currently already aggregated by other industries. The timber industry, wood chips going to pulp and paper. The sugarcane industry creating a waste stream of bagasse. The palm oil industry creating a waste stream of empty fruit bunches. For every ton of palm oil produced in this world, 9 tons of biomass. It's already aggregated, it's plentiful, and it's geographically dispersed. So, what do we make with it? Renewable chemicals, a demand in need of a supply. We start with our process with the biomass. We can fractionate it into its 3 primary components. It's hemicellulose, cellulose, and the lignin. We can then advance these basic products into advanced materials. Furfural from the hemicellulose, cellulose can go to advanced chemicals, materials, glucose to ethanol. The lignin itself is very special. It has advanced properties being studied greatly by researchers. The process itself is incredibly robust. We've already tested over 20 different biomass types. We've tested them dry. We've tested them wet, greater than 40% moisture. We've tested them clean and dirty. These are real-world problems that our process handles without degradation. The yields are important. In any industrial application, yields are money. We have yields greater than 90%, up to 95 and 96%. The purity levels allow us to take these 3 product lines downstream to create the high-value chemicals I talk about. Purity levels 96, 98%. This allows us to have the hat trick of revenues. We have 3 separate product lines creating 3 separate revenue streams. We don't use enzymes. We don't use microbes. The process is incredibly fast. We talk about processing in minutes versus other technologies in days. As I mentioned, no enzymes. We produce yields of glucose greater than 75%, and the total carbon utilization is over 90%. There are other alternatives out there, but none that we see that have the breakout performance that Glucan Bio's process has. So why is ours different? We use a solvent-based technology. The solvent is gamma-valeriolactone, or GVL. In small doses, this is actually used as a food additive, so it's a safe solvent. We talked about the biomass flexibility, gives us plenty of options. The hat trick of co-production, the 3 separate distinct revenue streams that we can build upon. And the capital required is modest. A commercial facility is about $45 million. Yes, we have intellectual property. We currently have licensed 5 different patents from the University of Wisconsin. We have 1 joint patent with them, and we have 4 provisionals that are currently in the works, and we think more will be coming. So the business plan is a joint venture in nature. We put in the technology, we put in the experience around commercialization and engineering. Our partner brings the financial capital. The model shows greater than 30% internal rate of return, greater than 30% returns. Now there are other similar business models out there. Burning biomass and cogeneration. Burn biomass creates steam to create electricity. This is old, tried, true technology. It's $140 million per facility, giving you an 8 or 9% return. I want you to think about, what would the growth rate be? Here we show 2,700 of these plants growing at 7% per annum. What do you think the growth rate would be with a 30% rate of return on a $45 million investment? So we start simple. We start with the commodities. This is what we've built into our business model, the commodity pricing. We move down the value chain to the intermediates and then to the specialty. Every time we move down the value chain, increasing the revenues, our returns go up. Where are we today? Well, we've moved through the lab, we've moved through bench scale, we've currently almost completed the engineering for the pilot facility, and now we're looking for $10 to $11 million to build a pilot facility to test the scalability of the technology. That's about an 18-month process, about 6 months of running the facility and testing it. Then we move to the commercial facility. As I mentioned, about $45 million necessary, about a 2-year time frame. Once that's complete, global mobilization. 6 of 7 continents this technology can be rolled out into. The team, a team of experienced problem solvers. Look, we have 170 years of experienced commercialization. We have 630 scientific publications, 29,000 citations. We do have early stage engineering scale up, as well as IP management experience. We are Glucan Bio. Thank you.
Larry, before we ask any questions, I mean, we want to talk about a little bit about your work in Malaysia and in that part of the world, because you're already doing stuff in the field to prove out biomass's potential for specific kinds of additives. And go ahead.
Sure. So I've had the great fortune of being invited to Malaysia, well, 3 times in 3 months. It's a long way there, right? 36, 40 hours for me to get there. Every ton of palm oil produced, they make 9 tons of biomass. They don't talk about a pile of biomass. They don't talk about the pile. They talk about how tall the pile is. They're having to take this biomass and put it in a landfill. This is a serious problem for them. The analysis that we have done with our technology, currently palm oil for Malaysia is about 8 or 9% of their GDP. We think we can actually equal that. So doubling that 8 or 9% of their GDP with our technology. Think about what that can do to a country like Malaysia, Indonesia, India, that was mentioned earlier, Central America. This technology with palm oil, it's a great partnership. We'll get higher revenues on the same land. We don't have to see additional land growth.
One of the concerns, of course, is the revenue model that the countries have for things like a commodity crop like palm, and the drop in commodity pricing and the drop in oil making it more difficult. But I think the value add that they can get from the process would more than make up for that kind of problem.
I look at this as strategy, right? I love the strategy piece of it. This is diversification strategy. You look at price of palm oil, it's like a cardiac chart. You take these and you extend these, it narrows the volatility of their returns.
Good point. Questions, please. Yes.
In that process, is it the palm kernel you're saying has
So this is the waste stream off of the palm oil. So they process the palm kernel, right?
Is it that part that you're talking about as the main bit that you're going to process?
No, they're going to extract. So they're going to extract the oil out of the palm kernel. There's an empty fruit bunch that holds that palm kernel, and we're going to start by processing that. It's called empty fruit bunches, right?
New Zealand buys a kernel from big cows.
Yes. So it's.
A waste product, we
Yeah, well, we don't mind you having to pay a little bit more, but it's okay.
That's cool, but you're looking at the fruit on.
Exactly. This is what's going into the landfill and causing extreme problems.
Yes, sir.
How far of geography around one of these plants do you have to pull biomass and really make it?
Excellent question. So our facilities, we talk about how fast this is. The size of these facilities, we think about 50,000 tons of dry mass. We can actually co-locate with next to one of these palm oil facilities, one of these sugarcane facilities. In the future, when we look forward to other biomass types being aggregated, and let's talk about the corn stover or MOG, material other than grain. We don't want to use grain. We think a 50-mile radius will support these facilities. So very logistically important.
Thank you, Larry. Appreciate it.
Okay.
Thank you.
Thank you.